Hello students, in this video we will be solving problems, or just rather one problem from exercise 7.2 and the first problem, because this problem is a big problem, so we will solve only one in this video. The first problem that we have under exercise 7.2 reads this way. It's in an isosceles triangle. Isosceles triangle is a triangle, if you recall, where the opposite sides are equal, and not only the sides, actually the angles are also equal opposite to those equal sides. We'll come back to that. It says in an isosceles triangle ABC with AB equal to AC, the bisector of angle B and C intersect each other at O. So these are the bisectors. OB and OC are angle bisectors of angle C and angle B. We are asked to also join A to O. We are asked to show that OB is equal to OC. These two sides are equal, and AO bisects angle A, which means we will need to show that these two angles are equal to each other. So let us begin with what we have been given, starting with solution. Now we have been given that AB is equal to AC. Fine. If AB is equal to AC and this is an isosceles triangle, that means the the angles opposite to these sides, the sides which are equal to each other, also got to be equal. That means this particular angle, full angle ABC and angle ACB are also equal to each other. We'll see triangle ABC is an isosceles triangle, which is given. We are also given that the sides which are equal to each other. So AB is equal to AC, which is also given. So we can say this implies that angle ABC is equal to angle ACB. So angles opposite to equal sides of a triangle are equal to each other. This is a property of an isosceles triangle. Now that we know that these two angles are equal to each other, what does angle ABC consist of? Angle ABC can be broken down further as angle ABO plus angle OBC. See, this full angle ABC can be divided, or rather is a total of these two angles. That is, I'll mark this way, ABO and OBC. So we can say they are addition of both of them. Similarly, we can say that of angle ACB as well. ACB, this full angle, can be said as a sum total of angle ACO and angle OCB. We'll write that ACO plus OCB. Now, we know that OB bisects angle ABC as given in this question. See, bisectors of AB, B and C, and OC bisects angle ACB, which means that these two angles got to be equal to each other. Okay, we will write that. So we'll say, but angle ABO is equal to angle OBC and angle ACO is equal to angle OCB, since you can say OB and OC bisect angle B and C respectively. Okay. And now that we know that ABO is equal to OBC, that means in place of ABO over here, we can replace it by OBC. So it will be OBC plus angle OBC equal to, similarly over here, we'll replace ACO with OCB because they are equal to each other. So OCB plus OCB. That gives us 2 times angle OBC is equal to 2 times angle OCB. Cancel this out and we are left with OBC is equal to angle OCB. So similarly, we can also prove that angle ABO is equal to angle ACO. So in place of replacing ABO with OBC over here, had we replaced OBC with ABO, we would have got 2 times ABO, and here we would have got 2 times ACO. Both would have cancelled and we would have got ABO is equal to ACO via same method. So we can directly take, instead of showing it one more time how we get to it, we can say ABO, angle ABO is equal to angle ACO. We can mark this as 1, we can mark this as 2. Okay. Moving further to solving the first part, that is OB is equal to OC, we will take, where is OB and OC? OB and OC are actually part of triangle OBC. So in triangle OBC, we know that angle OBC is equal to angle OCB, and we can say this is from 1 as we marked before. Now OBC and OCB, these are angles that are opposite to each other on in a triangle. So if these angles are equal to each other, that means the sides opposite to these two angles also need to be equal. Therefore we can say this implies that OB is equal to OC, and reason we can give that sides opposite to equal angles of a triangle are equal to each other. Okay, that's how we prove the first part, OB is equal to OC. Now moving to the next part, to prove that AO bisects angle A. For that we need to show that these two angles are equal to each other. To show those two angles are equal to each other, we would have to show these two triangles as being congruent to each other. If we show that these two triangles are congruent to each other, we can say that these two angles are also equal to each other as part of corresponding parts of congruent triangle. So let us try and prove triangle AOB as congruent to triangle AOC. So in triangle AOB and triangle AOC, what do we have? We know that OB is equal to OC. We've just proved that. We can write. Also we have been given AB is equal to AC. This is given in the problem. And we can also see OB is equal to OC we have been given. Then AB is equal to AC we are given. And we can take OA equal to OA, which is a common side. So we've got this side corresponding with this side, we've got this side corresponding with this side, and this side is common to both of them. As a result, we can say that these two triangles are congruent to each other by SSS congruence, or SSS, or side congruence, AOC. Okay, by SSS congruence rule or criterion. Now that we have got these two triangles congruent, we can take angle BAO is equal to triangle AO, and we mark this as CPCT, and we can then say this implies that AO bisects angle A. That's how we prove the second part of this. I hope you've liked this video. In case, please click the like button. Please share it with your friends and classmates. Please subscribe to the channel and do not forget to click on the bell icon to receive notifications when a new video is posted. Thanks for watching. See you in the next video.